All right, let's go over these now. The dorsal root ganglion contains, the correct answer is cell bodies of sensory neurons. Remember that the dorsal root is reserved for sensory axons. Okay? And they're connected to a nerve cell body through a unipolar process. Those nerve cell bodies are located in the dorsal root ganglion. So for number one, the correct answer is B. B. Number two, primary sensory neurons which synapse within the spinal cord are classified as, well, all primary sensory neurons within the peripheral nervous system are unipolar, B. So B, and then B again. So 2 to B. Number three, the posterior gray horn of the spinal cord contains, the correct answer is B. Okay. Somatic and visceral sensory nuclei. So this posterior gray horn contains somatic and visceral sensory nuclei. These are the nerve cell bodies of the second order neurons within that sensory pathway. In other words, within this posterior gray horn, the primary neuron synapse with the secondary neurons. Number four, another name for the pyramidal tract is A, cortical spinal tracts. Cortical spinal tracts. Number five, the upper motor neurons of the pyramidal tract synapse with lower motor neurons within, the correct answer is A, the anterior gray horn. Okay. So the upper motor neuron begins within the primary motor cortex. The lower motor neuron begins within the anterior gray horns. Number six, how many pairs of cervical spinal nerves exit the spinal cord? That would be 8. Number 9, all sensory tracts within the spinal cord synapse within, all ascending tracts synapse within B, the thalamus. Number 8, the ventral roots of the spinal cord contain, correct answer is B, sensory axons. Number 9, with regard to the spinal cord, CSF is located within, the correct answer is D, both A and C, the central canal and subarachnoid space. And finally, number 10, the structure which drains CSF from the subarachnoid space into venous blood of the superior sagittal sinus, that would be called an arachnoid villus. See, the three major basal nuclei cannot put glue on a pig.
I got the middle one.
I got the pig.
I got the
Is
P.
another
Yeah.
name for the sagittal, arachnoid villus and arachnoid granulation?
Yes. Yes. Okay. So today we're going to talk about the spinal cord. And I've drawn part of the spinal cord up here. Remember that the spinal cord begins at the foramen magnum and it terminates at the L2 vertebra, the second lumbar vertebra. Notice that this tapering segment near the end or distal end of the spinal cord is called the conus medullaris. The conus medullaris. Emerging from the spinal cord, you have 31 pairs of spinal nerves that emerge at regular intervals, or segments. Now, those 31 pairs consist of 8 cervical spinal nerves, 12 thoracic, 5 lumbar, 5 sacral, and 1 pair of coccygeal. All 8 of the cervical spinal nerves emerge from the spinal cord above the vertebra of the same name. So for instance, the C1 spinal nerves, I'm drawing them like this, they emerge from the spinal cord above the level of the C1 vertebra. C2, above the C2 vertebra. And that's true all the way down the cervical spinal cord. C4 is above C4 vertebra, C5 is above the C5 vertebra. Same is true for C6 and C7. But look what happens. Because we have one more cervical spinal nerve than we do cervical vertebra, then C8 is going to emerge above T1. So there's a transition point at T1 where thereafter all cervical spinal nerves emerge below the vertebra of the same name. So for T1, it comes off the spinal cord below the T1 vertebra. And T2 comes off below the T2 vertebra. And so forth, all the way down. All the way down to C1, yes.
Why is why are the cervical nerves the only ones that are different numbered than, like your actual vertebrae? Like there's 8 instead of 7.
Oh, why do you have 8 cervical spinal nerves instead of
Yes.
7? I don't know.
Okay.
No, that's just the way there is. It is. God made it that way. It's like, why is our head way up here, instead of down by our feet? There's some things that it's just the way God made it. That's just the universal plan.
Okay.
Yes.
No, I think it's a stupid question. I'm not going to ask it. Never mind.
Thank you for controlling yourself.
You're welcome.
All right. Okay. Now, notice that the spinal cord is much shorter than the vertebral column. The spinal cord ends at L2, the vertebral column goes all the way down into the cossageal region. So, what that means is because the spinal cord is shorter than the vertebral column, nerves that arise from the lumbar, sacral, and cossageal region do not leave the vertebral column at the same level that they exit the cord. Instead, what's going to happen is this, is that the dorsal and ventral roots of those spinal nerves that exit at these lower levels are going to pass down the vertebral column to the appropriate segment before exiting. So these roots, for instance, from L2, L3, L4, they're going to do this. They're going to pass down the spinal cord and exit at the appropriate level. You have a bundle of roots that are just coming down. And of course, for instance, the dorsal and ventral root from L2 are going to join and then exit right here. The dorsal and ventral root from L3 coming down the vertebral column are going to join together and then exit at the appropriate level. Okay? Because the spinal cord doesn't descend any lower than L2. But the roots to those more distal spinal nerves do travel down the vertebral column. In fact, this bundle of roots has a particular name. It's got a specific name. It's called the cauda equina.
Is that just in between L4 and L5?
No. Anywhere below L2, you have a bundle of roots that are referred to as the cauda equina, which means the tail of the horse. Why? I guess because these roots resemble a horse's tail. And this kind of shows the spinal cord here with the roof of the vertebral column open. You can see these bundles of roots that are descending down within the vertebral column, okay, until you get to the appropriate segment where they exit. At the time they exit, the dorsal joins the ventral and they form a spinal nerve. What do we call this little tapering segment right here? Conus medullaris. Okay? And this bundle of roots is the cauda equina. Where do we typically do a spinal tap at what level?
Lumbar.
Yeah, but at what level?
Between L1 and 2.
No, that would be a little too high up. You
3 and 4?
typically do it at L4, 5.
Oh,
And when we do it at that level, there's no risk of perforating the spinal cord.
Hmm.
Because the
book
spinal,
says between L1 and 2. so.
yeah, the book's wrong.
Okay. I'll go with what you say. That's where I got it from.
How
Yeah.
can the book be wrong like that though? I'm a little upset by that.
It says that actually in there?
Well, it says the spinal cord typically ends between L1 and 2, which is the ideal spot for, look,
I can't believe it says that. Inferior to that point. Oh, inferior to that point.
oh, so anywhere above.
So, yeah, you want to do it, in other words, they say you want to do it below L2,
Okay.
because if you draw fluid from that point, there's no risk of hitting the spinal cord.
Sorry, I
Okay.
Yeah, you can
I
make curveball
misinterpreted.
Geez, Sarah. Sarah.
That's
You
what
got
I
Jordan all upset.
No, I'm just kidding. No,
Okay.
I
Are
was
you
just,
okay, Jordan?
yeah.
Okay.
Just the stupidity of America. This is why I like Canada.
What?
I'm just kidding.
In fact, I'll show you something. Who
Oh,
wants to
geez.
volunteer? Okay. Jordan, maybe you can come up here.
Oh, again? I'm always on the table.
All right, so just climb on up here.
You volunteered.
I know.
Kneel like your
I-
friends.
Can you go ahead and lie down?
Calm down, Jordan.
All right, now to do a spinal tap,
Like on my back?
Fetal
all I want you to do is
position.
lie in the left lateral decubitus position.
To the side.
Yeah,
Fetal.
left lateral decubitus.
Like this.
Oh, this happened to
I want you to go, this is gonna be a little bit hard. I want everybody to come over here,
Oh, geez.
okay? Now, I want you to enter into the fetal position.
Fetal is like this.
Yeah, that's right.
I don't want my pants to fall down.
You said those are your pants, you don't worry about falling down.
We're-
Well, when I crawl into the fetal
Okay.
position,
Jordan, we're all professionals.
I don't think we are.
Okay. Now, what you're gonna do is feel the upper iliac crest. Now, when you feel the superior pole of the iliac crest on both sides, a line that passes through the superior portion of the iliac crest is gonna pass right through the L4, L5 interspace. So you're gonna go to the midline, at that point, at that imaginary line, and you're gonna pass the needle deep, and it's gonna enter right between L4 and L5. So that's where you typically do a spinal tap. Okay. Thank you for volunteering.
You're very welcome. Happy to model. Yeah,
Do you feel like, I feel like I've heard somebody say this, but maybe not. When you're doing the spinal tap, do you just like feel that you're in the right spot, right?
Well, what happens is, the first thing you do is use those landmarks.
Right.
And then you anesthetize the skin and the subcutaneous tissue, but you realize that you can't anesthetize everything. And then as soon as you start to advance the needle, as soon as it perforates the dura, it gives. So you feel a little give as soon as you perforate the dura, and then you start to pull back on the syringe. And you move the tip slightly further forward, and then you'll see a fluid come back out into the barrel.
What if it's red?
But once, no, it should be straw colored. But once you penetrate the dura, it gives suddenly. If you look, boom, like that, it's like a little give. Okay. Now, the spinal nerves and all peripheral nerves that branch from the spinal nerves are part of the peripheral nervous system. We mentioned that C1 emerges from the spinal cord above the atlas, C2 emerges above the axis. We said that for all of the cervical spinal nerves, they emerge above the vertebra of the same name, but the transition occurs at T1. Below T1, all spinal nerves emerge below. Now, those spinal nerves are going to pass through a little opening between vertebrae. What do we call that little opening through which the spinal nerves pass? Intervertebral foramina. Okay? Now, if you look at the spinal cord in cross-section. Remember, the gray matter is on the inside. Okay. And I think the way we've drawn this before is I've shown you a dorsal root and a ventral root that join to form the spinal nerve. That dorsal root contains only sensory axons, whereas the ventral root contains only motor axons. So that when they join together to form the spinal nerve here, the spinal nerve is a mixed nerve. It's going to contain both motor and sensory axons. So whereas the dorsal root is purely sensory, the ventral root is purely motor, the spinal nerve, which is formed by the junction of these two, is mixed. All right, you should be familiar with this. This is a cross-section through the spinal cord. It's a magic stick. What do I do with the magic stick?
It's right there, on top. Whatever that
Okay.
is.
Let's look at the different segments, the different regions of the gray matter. Remember the anterior gray horn, this can also be called the ventral gray horn, houses somatic motor nuclei. This is a cluster of nerve cell bodies whose axons exit through the ventral root and provide innervation to skeletal muscle. Lateral gray horns house visceral or autonomic motor nuclei. Again, because they are motor, the axons from these cell bodies exit via the ventral root and join the spinal nerve. Whereas the posterior gray horn, it's also called the dorsal gray horn, houses sensory motor nuclei. I mean, not sensory motor, but sensory nuclei. Both somatic sensory nuclei and visceral sensory nuclei. Now, as a point of clarification, a somatic sensory nuclei is a cluster of nerve cell bodies that transmit impulses from sensory receptors in the skin and muscle, skeletal muscle.